Okay, so what we're going to look at in this clip is an algebraic way of working out the gradient of a tangent to a curve at any point on the curve. Okay, so and I'm going to talk to you a little bit about what I've just written here. This thing called a derivative function. Okay, now if I have this function here, this is my f of x. Okay, this is actually f of x equals x squared. This particular graph, or y equals x squared. What I want is I want a function where if I wanted to work out the gradient, let's say at this point 2, okay, let's say if I wanted to work out the gradient at this point x equals 2, so the gradient of this tangent line here that touches this point here 2, I want a function where all I need to do is take the number 2 and put it into this function. Let me just put fun function, and then it spits out some number and it tells me how steep that tangent line is, or exactly how steep that tangent line is or should be. So instead of me doing it by eye, this sort of magical function is going to tell me what the gradient of that blue line should be exactly, and it's also going to tell me whether it's positive or negative or not. So if I pick another point on my line, let's say minus 2.5, and I draw a tangent here, and if I put minus 2.5 into this function and it spits out a number, it's going to tell me how steep that line is at that point. Okay, and it's also going to tell me it's positive or negative or not. So it's going to spit out a negative number, and then the size of that number will tell me how steep it is, and the sign of it's going to tell me if it's uphill or downhill. So this is what we call a derivative function. Okay, so we're going to be working out what that function is. This function is going to tell us how steep any graph is at any point on the line. Okay, so we're going to work that function out. I'm going to show you a method of how to work that function out for any function for that matter. Okay, now first of all, I'm going to talk to you a little bit about notation for it. Okay, so I'm going to use a lot of different notation now. So this magical function, okay, there's two ways of writing it. So first of all, if I was writing f of x for the graph, then the derivative function, okay, the function or the gradient function, the function that tells you the gradient at any point on the graph, is we say f dash of x, like an apostrophe here, f dash of x. Okay, so this, so for example, if I wanted to work out the gradient of minus 1 for this function, I'd put minus 1 into this derivative function. It'll spit out some number. It will spit out the number minus 2, and it'll tell me that this tangent line is minus 2 steep, exactly minus 2 steep. Okay, so that's one way of writing it, this f dash of x. Okay, right, if I was writing y equals x squared, or y equals whatever, really doesn't matter, then another way to write this same thing here is dy by dx. This is the derivative function as well, dy by dx. Okay, now the reason why where this comes from, dy by dx, if you think about how you work out the gradient of any line, okay, any straight line or a tangent line for that matter, you pick 2 points on your line and you make a right angle triangle, don't you? And you work out the vertical step and you divide it by the horizontal step. Well, the vertical step, okay, is the difference in y, dy. Okay, dy, the vertical step, difference in y. And you divide it by the horizontal step, but that's the difference between these two x values, or dx. Okay, so you're dividing it by the horizontal step, which is dx. So dy by dx is another way to write the derivative function. Okay, it depends on which notation you started with, that or f of x. Okay, so what we need to do now is work out what this magical function is. Okay, so let's look at the principle behind it. Now let's backtrack a little bit. Remember what we did before when we were working out the average speed. Actually, let me use this here. Remember we were doing the distance time graphs in our first clip, and we were working out the average speed. And what we were doing is we were taking 2 points on the line like this and joining them up and working out the gradient of the straight line that joins those two up. Okay, but then I said to you, you know what, that is the average speed between these 2 points, but if I wanted to work out this speed at this dot here, this point here, then I'd need to draw a tangent line. But we thought about it as maybe picking a point close to the first one and then joining those up and making a straight line, but then getting closer and closer and closer and closer and closer and closer, right? So making tinier and tinier and tinier dots. Okay, and then we approach this tangent line. So let's think about that algebraically. Okay, so let me draw my horizontal axis and vertical axis, and let's think about this algebraically. Now, let's concentrate on the right hand side of the graph. So let me draw my f of x there. Okay, now let's think about it algebraically, and this is how we're going to do it. So let's say I want to find the gradients at this point x. Oh, by the way, I need to say what this method's called. Okay, so what we're doing now is we're trying to find the derivative function, the f dash of x, or the dy by dx. Okay, the derivative function. But the process is called differentiation. Okay. Okay. To find the derivative function, we're doing this process called differentiation, and the method we're using, there's lots of different ways to differentiate. We're using differentiation from first principles. Okay, so we're going to differentiate from first principles. So we're going to find these derivative function, the process that's called differentiation, and we're using this process called first principles. Now let's say I want to find the gradient at this point x. Now let's say I go a fixed distance across. Okay, so I start at x, and on my horizontal axis, my x-axis, I'm going to go a distance h across. Okay, now what would be this point here? Well, if my gap here is this h is just some number I've chosen, maybe 5, maybe 4, maybe 3, then this point here, this point would be x plus h, wouldn't it? X plus h. Now, if I go up, let me go up to that dot. Let me do it like that. Okay, so imagine that line was straight, which is clearly not. Okay, so that's that point there. Now, imagine I join those up, and I want to work out, like before, you're picking 2 points on the line. That's all we've done, x and x plus h, and we put 2 points on the line. I want to work out the gradient of that blue line that I've just drawn. So what we do is we draw a right angle triangle like this, and we work out the vertical step and the horizontal step. Now, the horizontal step is easy because I've chosen what this gap is here. I've chosen it to be this value h. But the next part is to work out what the vertical step is. Now, what we need to do is think about the coordinates that we have. This coordinate is, well, okay, if it's that coordinate, it's x across, okay, and then to work out how high you go, you just take that x and bung it into the function, right? You work out f of x. So this value here is f of x. Okay, so whatever value of x you have here, you put that value into the function, it tells you how high to go up. So that's f of x. Well, what about this one? What about this coordinate here? Okay, what's that height got to be? Well, that coordinate, well, we know its x component, it's x plus h. So what would be its y component? It would be f bracket x plus h. You just take that value, whatever x plus h is, and bung it into your function, and it tells you how high to go. So this is f of x plus h. Okay, now, well, then what's the vertical step going to be? Well, the vertical step would be the difference between these two y values, the difference in y, the dy, right? The dy part, that. So you would do f of x plus h, which is the height, subtract f of x. Right, that's the vertical step here, that's how long this bit is. Now, what would be the gradient then? Okay, the gradient would be f of the blue line, sorry, the gradient of blue line would be f of x plus h, take away f of x, and then I have to divide it by the horizontal step. Now, but the idea of this was that when we worked out the average speed, we said, well, we don't want the average speed between 2 points. I want to work it out at exactly x. So what we do is we move this point in a bit. So to move that point in a bit, I need to make h small. So make h smaller. Okay, make that choose a smaller value. So I think I said 5 before for h. We'll make it 2, or make it 1, or make it 0.1, or make it 0.001, right? Just make it as small as possible. Or how about you make it infinitely small? You make it smaller, you just continue making it smaller and smaller and smaller forever, right? Then you'd start approaching this value here, right? You start approaching the tangent. So what we're saying is this: we want the limit, we want h to get as small as possible. We want it to get to 0, and then well, we can't divide by 0, but let's get really close to 0, and then we'll have our derivative function. We'll have our f dash of x. Okay, so our derivative function is this. Okay, now let's actually do that with some numbers first of all, and then we'll look at how to do this process algebraically. Okay, so how to do this algebraically. Now, right, let me get my derivative function here. Okay, so here it is here. Okay, now let's say I want to work out the gradient at x equals 1 here. Okay, so let me actually do it on this as well, right? Okay, oops, I want to do it on this, right? Now, this is x equals 1. Okay, this is x equals 1. Now, at the moment, I've set h, here's my slider, I've set it to be 1.6, and you can see I can make it smaller and smaller and smaller and smaller and smaller and possible, right? If I get to 0, it disappears because there's the tangent line. You see that blue line? It's the tangent line. When I get to 0, it disappears because computers can't divide by 0. But if I make it 0.1, it appears, right? As long as it's not 0. But let me zoom in on this. Okay, so let me zoom right in on this gap here. Okay, so can I zoom in? Right, can I click on that? Right, okay. Cancel. Okay, so I want to zoom in, please. Right, zoom in there. You can see that's really tiny there. Okay, now that's h is 0.1. Now, okay, you can see 1, and that's 1.1 there. And you can see it looks like it's the tangent, but it's not. I mean, if I zoom right in, you can see that there's a gap appearing here. Can you see that gap appearing there? So it's not quite the tangent. So I need to get really small. Okay, and then my slider, unfortunately, I can't adjust it. Well, I don't want to adjust it. Let's say it's not I can't adjust it. I don't want to adjust it to anything smaller than this. But we're going to do it algebraically. Okay, so we'll do it numerically. Okay, so this is a graph of f of x equals x squared. So this is f of x equals x squared. Now, so let's set h to be 0.001. Okay, 0.001. Right? Okay, so something like that. So first of all, what is it that I have to do? Okay, so to work out the gradient of that blue line between these 2 points, imagine that was 0.01. This would be 1. This would be 1 add 0.001. So this would be 1.001. This one here. So there's 1. And then this gap is 0.001. Okay, so just imagine that it is, okay? Right, now, so going back to the function, I have to divide by 0.01. Sorry, 0.01. Okay, that's my h. Now, I have to work out f of x plus h, or f of 1 plus 0.001, which would be 1.001 squared. Right, let me try and work that out on the calculator. So that squared is 1.001 squared is, okay, it's not very nice, but it is 1.002001. So this point here is the height of it above the x-axis is 1.002001. Okay, now I have to subtract my f of x, right? Or, well, what value of x have I chosen here? I have to subtract f of 1. Okay, so f of 1 would just be 1 squared. Okay, you know, f of x 1 squared, so I'd have to subtract 1 and divide it by 0.01. Now let's see what that works out to be. So subtract 1 divided by 0.001, right, we get 2.001, which is not far off the actual value. But the idea behind this is that if I want to work out the exact gradient at 1, I need to make this value even smaller. So I need to make h even smaller, like 0.00 something. Okay.